Hi, very warm welcome. I'll try and be brief in this video because there's quite a little bit of technical stuff that I want to get through. Obviously, I'm sure some of you have already worked out what we're looking at. We're looking at a utensil, which is, you can buy for about £6 yourself if you want to play around with electrolysis, producing hydrogen and oxygen by adding some electric to it. And on the right hand side, you've got a hydrogen fuel cell. The both are very similar to each other. In fact, with just the hydrogen fuel cell, you can generate hydrogen and oxygen by connecting positive and negative up to the cathode and anode. It will produce in reverse hydrogen and oxygen. But the unique thing about a hydrogen fuel cell is if you put hydrogen gas on one side and oxygen gas on the other, you produce electricity. Now, before we go on any further, you know what? I want to say a big thank you to those few people, without mentioning your name, you know who you are, for help supporting what we do. I've been ordering quite a lot of stuff lately and getting a bit concerned, especially in the current crisis that we're all facing, financially. Just concerned about the levels of, funds that we're able to raise, because it's always the stopping point for me. If I haven't got the funds, I can't obviously invest, and I can only do so much with even being as talented as I am in various areas and building some of these devices. I can only be as talented as really what the funds will allow. But I want to tell you right now, so that I get your attention, I have discovered a very unique way of producing electricity. I'm going to go through it in this video today with you, and over the next few days I'm going to show you the experiments and the results that we're getting out of it. It's quite interesting. It starts with electrolysis and hydrogen fuel cells. Now, the problem is that we're facing, as a species, let's say, it's not just related to, it's the cost of production of energy. And of course, there's a lot of emphasis on clean energy. And when we look at all the different ways we produce electricity, we've got hydro, which is used, basically, we're dropping water from a height. The weight of the gravity of the water turns a hydro turbine, and that produces electricity. That's good if you live by, a very high source of constant flowing water. You can generate electricity like that. Here in the UK, we pump water. When we're producing a lot of energy from wind and solar, we pump water up to a higher altitude, leave it there as a sort of a battery, and then when we need that water and the electricity produced by the water that turns them hydro turbines, we let it fall back down. It's an expensive way of producing it, because you have to use electricity to get the water up to the top in the first place. So, these hydrogen cells are really good, but only if you've got a lot of hydrogen gas. And there are a lot of ways of creating hydrogen gas. I can create hydrogen gas using potassium hydroxide and putting some aluminium foil in that potassium hydroxide. It fizzes off, giving hydrogen gas, and you can run one of these fuel cells. But that's not the best way to run a hydrogen fuel cell. The problem we've got with hydrogen fuel cells is that hydrogen is a very lightweight gas, and therefore the majority of the hydrogen in our atmosphere is not at surface level. It's in the higher altitudes. So what we have discovered through recent technology is that we can actually use direct air on the oxygen side, so we don't have to provide it with oxygen gas to get the electricity out. So long as we provide it with the hydrogen on the other side, we can generate electricity with fuel cells. And it's this sort of method, if you have heard of the talk of hydrogen cars, hydrogen fuel cell cars, basically they've got a pressurized tank in the back, and it's allowing that hydrogen gas to flow over the fuel cell, which produces the electricity to turn a motor in the car. Now, wouldn't it be great if we could do away with one of those most explosive gases, especially when it's mixed with oxygen? We get what's called Brown's gas, and it is very explosive. When you're producing hydrogen and oxygen gas, if they come together and there's an ignition source, it will explode. So if you don't know what you're doing with these things and you just want to take precaution, just leave them alone. Simple as that. So we got the problem. Hydrogen is not readily available for the other side of the fuel cell at, let's say, sea surface level, or on the ground. If we could add a free source of hydrogen to that side of that fuel cell, we could generate as much electricity as we wanted. And I've been looking into this technology. That's why I haven't been doing a lot of videos, because I've been really racking my brain on all this, looking through the chemistry of how the fuel cell works and the electrolysis, and what really is going on with the water and oxygen molecule the hydrogen and oxygen molecule that make up the water molecule, should I say, or the hydrogen atom and the oxygen atom that make up the water molecule. I know people will correct me if I don't get it right, so I'm doing my best. So what did I come up with? Well, I told you I was going to start throwing lots of different new technologies that we've recently discovered, or relatively recently, at this problem. I come up with something, a solution that actually works. I'm quite shocked, and over the coming days I'm going to show you what the results are of that. Now, I will tell you very quickly, what's going on in that fuel cell is an exchange of electrons. So, if we haven't got a readily flowing hydrogen gas on the one side of that fuel cell, it won't work. I found something else that does work though, and something that can produce relatively easy, and increasing the surface area of the collector, we can produce quite a lot of it. And what is that? Ion wind, or ionic wind. And you might have seen this used in people building these ionic lifters. It's the exact same thing. What it's using is a pointed electrode and a very smooth rounded electrode, and we'll put in high voltage at or should I say around about 1.5 amps at 3 volts, which isn't a lot. That works out at 4.5 watts, which is not a lot, but you can create a lot of ion wind. And if you direct it on the one side where the hydrogen goes on that fuel cell, it works, guys. I'm going to show you that in a few days time. I've got some stuff on order. I'm just waiting for a few things to come. But what is the exciting thing about this? Okay, let's not get ahead of ourselves. Okay, I will tell you what I've got so far, and there could be a lot of reasons for the results I've got. I am putting 3 volts in. I can get 8 volts back out. That's not a problem. But what are the milliamps that we're getting out? That's what we want, usable electricity. Because my point is, if we can do away with hydrogen gas on the one side of that fuel cell, and use ionic wind on that one side, and then oxygen on the other side, which is readily available at sea surface level. We got 20%, as you know, because I do the atmospheric oxygen when I do the Earth Alpha at a glance. So we've got plenty at sea surface level, or at land level. So we can use the oxygen on the one side, and using ionic wind on the other side replaces the need for hydrogen gas. I've got, like I say, some good results, and I want to show you those over the next few days. But I want to show you what is going on. I'll show you how a fuel cell works, where it's nicking basically the electron off the hydrogen atom, and then when you put it in an electrical circuit, it runs through the circuit, that ion does, and out the other side of the fuel cell, what you're getting back is that ion connect with the hydrogen and the oxygen. You're getting water back out, so the exhaust of the fuel cell is really clean exhaust, so you're getting water basically back out, or H2O back out the exhaust. But the unique thing here is we're using ionic wind on the surface of where we would normally use hydrogen gas. That's the difference. So we're just adding that electron to the plate using ion wind. And I can produce, like I was telling you guys, I can produce 20 grams of thrust of ion wind quite easy at very low levels of input of energy. So 1.5 amps, 3 volts, 4.5 watts of electricity isn't a great deal at all. It's a lot less than what your fridge uses at home. So that gives you an idea. of how easy it is to produce. The other thing is, it's not explosive gases that we're using. So there could be a potential there, but the big thing is here is I've never seen anyone use ionic wind on one side of the fuel cell like I am and getting a result out of it. We are producing electricity, is what I'm saying. So yes, you have to use a bit of electricity to produce the ion wind. You can scale up the ion wind production by surface area. So it's not a problem with, you know, the amount of ion wind that's required, but I'm producing very, very small amounts in comparison. You know, less than, well, let's just say less than 1 mile an hour, as opposed to the potential of probably 6-7 miles an hour of wind or force, or 20 grams worth of force of ion wind. So I wanted to share this at least with you for now. I know it's probably mind-boggling, but you know, this is what we need to do. We need to keep investing time and effort into finding alternative sources of producing electricity, because when we do, we then give ourselves a lot of freedom. If electricity can be produced at such a low cost and it's clean, we've answered a lot of big problems for what we're facing right now. You know, one of the most expensive things in our daily lives is the production of energy. And like I said, I know that if the government had have invested half the money in what they did in that Hadron Collider, which hasn't really changed anybody's life at all, or half the money they've invested in fusion technology, which to me hasn't shown any positive signs yet, because they've not got one single fusion reactor running at this point in time, constantly producing electricity. And we know the fors and the againsts for wind and solar, and then, you know, the problems with hydro, and then you've got your problems with nuclear power. You know, you've got to store that stuff for 30,000 years, all the waste that comes off it. Even though the initial production of energy is clean, it's potentially dangerous. Whereas if we can come up with another alternative to burning coal or something like that, then, you know what, we do give ourselves a certain limit of freedom back. And that's what I'm trying to do, as well as the other things that I do at this observatory anyhow for you guys. I just wanted to share this with you, because I know that none of you will have ever heard of anyone introducing ion wind and replacing hydrogen out the hydrogen fuel cell to get electricity to be produced. But we've managed to do it here, and do it within probably about 3 weeks worth of research on it. And I'm sure the results and the experiments I'm going to show you is going to encourage a lot of people to now go back and look at this technology and, you know, ponder whether this can be, you know, the next progression of the fuel cell. Let's see. But right now I just wanted to let you know what I was up to, and I'm just waiting on a few other components, because I want to make this really interesting and easy for you to understand what's going on here. And I know when I'm talking about this and just showing you a picture like this, it's very technical. So yeah, over the next few days I'll show you exactly what we've got with results, you know, so that you know what I'm saying is actually right. You know, this is, as far as I'm concerned, it's another step forward in the progression of understanding how to produce alternative sources of energy. So big thanks to those that are supporting us. I'm still here, guys, don't worry. We will do another positioning of the magnetic North Pole. I know that's what a lot of people come for, but you know what, this should be interesting to you as well. I'm sure it is. Guys, you take care of your loved ones, as always. Bye for now.